Hey everybody, welcome to our next session, the RenderMan Art and Science Fair, discovering RenderMan Stylized Looks. I'll be talking a little bit about the stylized looks with some special guests. First of all, my name is Dylan Sisson. I'm in the RenderMan group, RenderMan specialist, digital artist, manage the marketing and all that kind of good stuff. And I've been recently diving into the stylized look, so I'm going to show you some of my work with it. We also have Christos Obretenov. He's the lead developer on the NPR or Stylized Look project. And we have a conversation with him. Christos, unfortunately for us, but fortunately for him, is on vacation in Tofino in Vancouver, BC. So in the chat box and in the Q&A, if that works out. And we also have Ernst Groesbeek. He's an early adopter of the RenderMan Stylized Look technology, and he has some really cool projects that we're going to do a little case study of. So let me just bring up my media here. And so RenderMan Stylized Looks. First of all, you can see that teapot. That's the onward teapot. That is not a stylized look. That is physically based rendering. So what's a stylized look? It's that. We're taking the same data and we're creating a look that looks like, in this case, an illustration, but it could be a Toon Look or it could be some other kind of look, even painterly looks. So let's kick things off with the interview with Christos. He's in conversation with me, and on a sunnier day when I was on my deck, and we have a special preview of some anime tests from Toy Animation as well. So without further ado, let me bring up the conversation with Christos. And I am finding my conversation with Christos in this browser. I'm here with Christos Obretenov. He's the lead developer on the new RenderMan Stylized Looks. So, hi, Christos.
Hey, Dylan. Hello, everyone. Thanks for having me. Great to be at the virtual Art and Science Fair.
Yeah. It's so far it's been terrific.
I'm missing having our RenderMan Martini. Or Martini. What was it called?
It's the Render Manhattan.
Render Manhattan. Sorry.
Yeah. It's not only is it tasty, but it's a funny play on words. We're kind of fortunate to be talking to you, you've been working on stylized looks for a long time, kind of these NPR looks. You started back in the Raise days with RenderMan 19, I think.
We've been doing it for a while. Maybe even pre 19.
Pre 19.
Yeah.
So like 18?
I think so. I think RenderMan Raise 18, because 19 was RIS, kind of hybrid, and then we always were keeping up with the technology, so constantly sort of porting it and bringing it to the very latest version of RenderMan. And then the newer stuff in RIS gave us a lot more flexibility to really go off the pixel with some of the off geometry stylization, which hadn't been possible before. So as we started kind of prototyping it out back in RenderMan Raise, it was more of a multi-pass thing. So now, and for a little bit now, it's like everything's in one pass.
Yeah, the one pass solution, as far as RIS goes, that's what it really delivered to the table was removing this need to do a bunch of pre-passes and bakes before you actually rendered your shot. You could just render it in one go. And having that same philosophy, not only with your physically based materials, but with your stylized looks, is also super powerful.
Yeah, exactly.
And can you talk a little bit about how you've approached integrating the stylized looks into RenderMan? So, just to back up, it's not a compositing workflow, but it's something that allows us to do live rendering. We can do the IPR rendering and then start creating the look. but on a deeper level, how you've integrated it into the system, into kind of the brains of RenderMan by piggybacking on some of the existing technology and not replacing it.
Correct. Like, because you could go into different directions where you write like a brand new renderer that has stylized looks, but then we'd have to constantly keep up with everything else that's photoreal, and we don't want to necessarily go down the road of like just one particular style. Like, we want to keep it open for different styles, and then especially we want to be like mixing and matching maybe like a photo surreal look or a photoreal look with a stylized look, kind of all in one thing. So we wanted to make sure that we kept it sort of piggybacking, like you were saying, off the latest RenderMan technology. So you can choose any integrator you want with RenderMan, whether that's a path tracer or a bidirectional path tracer or any path tracer or integrator that RenderMan might release in the future. So we kind of work with that, and then we sort of go into different directions to stylize all those different looks. So if you've got a new Photon Path Beam Super Deluxe VCM coming out in 2022.
How'd you know?
I just put all the words together that you guys have done in the last 3 years.
Right.
And I added the word super.
Yep.
We don't want to keep up with that. We'll kind of piggyback off of it, and just it's a deep integration. So we're going to get all the separate kind of light path expressions and data from that. So we built around that, and then also have per kind of object per shader control. So sort of right out of the box, you can sort of have some global stylizations, but then in practice, in production, users will want to tweak certain components of a character or a set or a background or object or a car. So we want to be able to integrate that way, where they can do that sort of at a very local level. And then we've also added, on top of that, we don't want to just keep it in the materials. We also want to have lights. So we give the power to the lighting artist or the cinematographer. And now you can have like sort of an NPR light, and that's just kind of a concept. That's why I put it in quotes. It's not a different light. Again, we're piggybacking just like we are off the RenderMan integrators, off the RenderMan lights, and somebody can have 10 lights in a scene. 9 of those can be physically based, and then this one over here, that's like a Toon or like a hatching or an illustrative light. And as we move that through the scene, everything that lights gets that stylization. So you can imagine how sort of creative one could get with those different options.
Well, you had one slide in one of your previous presentations that still sticks out in my mind. I think it was don't dumb it down. Like you have this really powerful modern path tracer, and one of the goals was to implement a system that allows you to do stylized looks without just like using it as a mechanism of outputting things. You actually want to harness the actual brains of the renderer.
Yeah, and that was sort of because some of the styles that we go to, like maybe we do some anime and Toon, we want to make sure we're not just going backwards in technology, because there's been some fantastic advancements in photorealism, but also sampling, subsurface scattering, et cetera, and some of the stylizations are in essence can be a simplification if that's what's kind of desired by the story, but we're not like dumbing it down and saying, oh, we're going back to rendering in the 90s when all we could do is Toon. It's using the very latest integrators and lights and sampling, but just going into different directions.
So you did some nice treatments of the Onward Walking Teapot for 2020.
The new teapot, always exciting.
Always exciting. First time it's been AR, and this video is pretty exciting too. Can you tell us what's happening in it?
Yeah, so we've got the lovely new teapot, and because I love split screens, I'm just doing a few different treatments on it. And we start off with this awesome render of the teapot, and then we start stylizing it with this kind of Kuwahara implementation, and Kuwahara is like a paper on like brush kind of smearing technology that we're testing, and it doesn't have the brushes going like way off the geometry, but it was really stable over time. And then we have a few kind of more wild and wacky tests where we have actually like brushes going way off the geometry. So we're back to the Kuwahara here. Here we bring the brushes way off the geometry, but we do modulate them based on sort of a focal point. So you can see that the teapot is in focus as we go in and out. We get like a lot more brushes on these purple kind of bars, and then we bring in kind of the broad brushes on everything, which are actually slowly rotating as we're watching it. So that can get distracting, obviously. So we sort of use that in, you know, particular instances, and then we can have different settings in those plugins to actually not have them jumping around that much. They might stick to a certain part of the geometry, but we do want to dynamically move that a bit because we don't want it totally just flat static sticking. So like once you start going off the geometry with brushes, you can go into so many different directions. But the key is we're using, again, the deep integration where we're using all the 3D information we're getting from RenderMan. So this is a original shot from Only a Dream, and that's a film that is being worked on by some folks at Pixar. And here we have deliberately slow-mo. I rendered this out at 6 frames a second just so we can see some stuff. So this has, you know, quite a big radius of this Kuwahara filter run on everything. So we're just running on everything just to see what it's doing. And it looks really cool with the hair. The eyes are kind of weird, so we wouldn't, you know, apply it on the eyes. Perhaps you can do masks, but like right there at the end, I think it's on her screen right above her eye. It's kind of cool. This like brushed sort of where her eyebrow is looks really neat. And then this one, we're using the camera depth. So she's in focus. This piece of hay that she brings up, I think it's kind of neat because it goes in and out of focus. We often talk about what happens in the background, and people want to blur out the background and or do more of a painterly background and whatnot, which we're certainly doing here. But also it's interesting when things come, you know, very foreground and they're out of focus. So if watch here, and this is why it's rendered slow, this piece of hay, like it just quite has this smeared sort of painterly look, and then she brings it up into focus and out of focus. Like I think that's cool because we've been seeing these, you know, traditional camera depth of field, which look fantastic. You know, it's blurry, but let's make it something else, and let's make it more deliberate instead of just blurring it out. Maybe we bring in some brush strokes there or some line work. And then when it comes in focus, we still see the power of RenderMan. It's the very latest.
Yeah, this is a great example. I think it's from a co-op short at Pixar, one of the employee projects.
Oh, yeah.
Only a Dream, yeah.
Yeah,
You mentioned
Only a
the
Dream.
title, yeah. And I think Leif Peterson on the RenderMan group was working on it.
Yep.
So he wanted to run some NPR tests on it. So,
and we always want to test the stuff on kind of animated examples. So which we're doing as much as we can. A lot of folks want to, how does that look? How does the hair look when it's animated, and etc. So it's easy to do stills, but stills you can't really describe, like what does it do over time. Obviously, like it looks great, but how did you put it together, etc. So we're trying now to do more and more those live demos that we looked at, showing like this is in RenderMan in one pass, like look, and it's happening, and B, doing these kind of animated ones with hair, etc. Just to, what does it look like animated? So that's why it was great to get Leif and the rest of the team on Only a Dream to to be able to use the shot. And we're continuing testing on this. These are just kind of early tests, so we'll see more of these as we try the different techniques on these animated tests. We find that as a sort of a base default, if you have deforming and animating geometry with a moving camera, so sort of like everything, doing like a blended triplanar projection with like a PREF rest position point has all the brush and the hatching textures be very stable, but then it just comes down to a look. Like, so maybe the blended triplanar isn't great because it's blending brushes, so you might want to do a camera projection. Screen projections look fantastic for things that aren't moving because you just really it looks like they're coming off the page, but we're in a 3D world, so it's using the blended triplanar or custom camera projections just to get everything in there.
That's pretty cool. So you're essentially using the tools that exist in 3D, and you don't have to reinvent anything or emulate that in compositing or something.
Correct. Especially for all the 3D data that it already exists there. People have been using these projections for many things over the years. So let's just, again, piggyback off of those, use those, but we're feeding them into the stylization, and then it becomes, like we said, just a matter of taste, art direction. Maybe the brushes are too static. Maybe they're moving around too much. Everybody wants something different because there isn't any, it's not on a plate where it's like, oh, that's not photoreal. It's like, we want it to go way off the geometry. Actually, that's too conservative, whereas somebody else might think the other thing is just way too out there and distracting, and nobody's right or wrong.
Well, like physically based rendering, you have ground truth, so whether it's right or wrong, and you can say, well, I'm going to cheat this thing or exaggerate that thing because that's part of the style. Maybe they have blue skin instead of normal skin, or pointy ears, or whatnot. But when you're going into full stylization, it really comes down to like your artistic reference as far as being able to create a look. You really have to define what you're trying to get to before you start even creating it. At least that's what I've discovered. And we have up next, I think we have Ernst Groesbeek. He's one of the early adopters of the stylized rendering technology. I think you know him quite well too, Christos. And he has some cool work he's done for a model that we rolled out on our Ship Shape Challenge. Yeah, thanks for joining us.
Thanks for having me, and looking forward to seeing what the folks can kind of creative things they can do with the technology.
All right, great. Well, we'll catch you later.
Thank you, everyone. Render Manhattan time.
Render Manhattan time. And we're back. That was an interview with Christos. He's the lead developer for our Stylized Look technology, and he's also lurking in the chat box. He's on vacation with spotty Wi-Fi while he's surfing, so lucky Christos. I'm going to show you a couple things that I've been working on before we dive in and talk to Ernst. And one of those things is this stylized look for this teapot, which is actually animated and walking, and I wanted to kind of break that down for you and show how we can approach applying these standardized or stylized looks to an animated object. So this is buffering on the next pass here. It should become in a higher resolution here. So now you can see the nice physically based rendering. The switch to the stylized rendering, you can see there's where the light is striking the teapot, the lines are white. Where the cross hatching is on the teapot, it's actually orientated towards the light that's pointing at it. So it shifts a little bit, but is always pointing towards the light. And on the teapot, it's horizontal, and on the feet, it's vertical. So keep that in mind as I break down this lesson in just 1 second here. So you can see that it's not swimming through the teapot's not swimming through the textures, and it's not also having the textures stuck on it. It's kind of in the middle, kind of a squishy texture. So let's take a look at that. And in this slide here. So first of all, how does this all work? If you've used stylized looks before, you'll know that it's usually kind of a post-process or a compositing process where maybe you'd render out a bunch of AOVs and secondary passes, assemble them in compositing. So that's nice because you can get an NPR image out of that, and you can make it, you have a lot of control on how it looks. But if you're modeling or animating or running a simulation, you really have to render out all the AOVs, do all the kind of smart bits in to make it look like a stylized look in compositing, and then get that compositing back to see what that your work even looks like. With the technology that we're going to be implementing and shipping in RenderMan 24, we've taken a different approach. So we have basically upstream workflows that we're using so we can avoid creating these really complex compositing networks. So, you know, if you're doing everything compositing, you have a bunch of different passes and you have these complex networks. We've simplified that, so we have upstream workflows. So I'm modeling or I'm animating and I want to see the results of it. I can actually see it immediately during an IPR session like I do with physically based rendering. So I can create all the compositing operations or all the stylization operations upstream, just turn on my live rendering session and kind of fiddle with those. And then I get my NPRS image out at the end. And if I want to incorporate compositing in Nuke, I can do that as well. So how does it work? The basic recipe is that we have these NPR pattern nodes that basically plug into your current shaders. So we have the Pixar surface shader, and you have probably, if you're using RenderMan, a bunch of scenes that have Pixar surface shaders. You can plug in the NPR pattern node into the utility connection, and it converts it over to working in kind of this stylized look. You don't have to get rid of your old shaders. We use live AOVs, which provide signals to our NPR display filters to create stylized looks. And we have different display filters, including lines, toon, hatch, and painterly. And over here on the left, you can see the PBR teapot, and you can see a number of different treatments of outlines. And these are all created using one display filter. Some of the outlines have kind of like noise and are kind of broken up and look a little more like charcoal. Some are driven by the light. So where the light's hitting it, the line's thicker. Where there's no light, there's no line. And there's lots of different things where we're even capturing the albedo from the textures on the surface and doing kind of some crazy stuff. We have a Toon Look display filter. So the Toon allows us to basically take our diffuse signal, pipe that into a shader, and then kind of do these banding things. And here I've added a little bit of roughness just to break that up. But the nice thing about the system is that if I wanted to take the specular and pipe it into the Toon Look, I could do that, or really any type of secondary pass that I wanted. Powerfully, we also have a hatching look, and the hatching look can actually create a Toon Look. In this case, for the walking teapot, I used it to create this hatching look on the left, and I created a series of 8 progressive hatching textures. I drew these by hand, and you can basically create your own textures and make it look, make your own kind of unique look by having your own custom progressive textures. So on the right here, you can see more of a watercolor look for this teapot. I've basically created a set of watercolor progressive textures, applied them to the same teapot in the same scene, and got this result. And by feeding that the albedo, like the surface color, I could change the color of the teapot, add a lot of different types of effects to it. So it's a flexible system. And there's painterly looks too. So this is something that we'll be implementing for either R24 or R24 dot something, but we'll be able to draw lines off of geometry, change brush sizes, and do all sorts of nifty things. So the system is really able to handle a lot of different stuff. And just to show you how we wire this together, first, here's my teapot inside of Maya. And I am basically wiring up the NPR using a hatch display filter. You can see the hatch display filter over here on the right, where I basically loaded up all my 8 textures on the bottom, and I have a number of different controls that allow me to control how that progressive texture is mapped onto my object. And you can see over on the left, all my different display filters that I can plug into my scene and turn on and off and enable as I want to. With my display filter, hatch display filter, if you look over here on that little blue box, I have a projection control. So I've set that to triplanar, and that allows me to wire in a triplanar projection. And if we look here, you can see that I have my Pixar surface shader in kind of the hyper shade there, and there's a pattern node being plugged into that, into the utility pattern. The NPR pattern node has all the brains over there. If you look in the attribute editor, you can see all the controls that the pattern node has. And I'm able to plug in a triplanar projection into my pattern node, into my Pixar surface shader, And by taking my coordinate system here, so I have my Pixar 3D manifold, I've referenced a coordinate system in the Maya scene for the teapot body, and I have different coordinate systems for each leg. And so each of those coordinate systems has different orientations. So by changing the orientation of the top coordinate system, I can have horizontal lines on my teapot and vertical lines on my feet, and I've animated them. So over time, the coordinate system's always pointing at the light direction. And in that way, I have a lot of control of how those textures are being mapped onto my objects. And at the same time, like we were talking before, we don't have a bunch of invasive technology. We're kind of piggybacking the stylized looks on existing technology in the RenderMan scene. So we're using the Pixar surface shader, we're using the Pixar manifolds, and just inserting as little information in there as possible to create the stylized looks. So to break down this look, we have a display filter that creates a background, a line display filter that creates this lighting, color from lighting. So I have just kind of a constant line whose line color changes if it's being illuminated or not. I have a Copic marker, it's more of a washed line that gives it a little more kind of detail inside the teapot. I'm using a specular highlight, and I have a little bit of hatching here that I just showed in the display filter. And then when we put them all together, we get this final look here. So that's how all that stuff is kind of wired together. And it's fairly straightforward. And if I wanted to switch back and render it with physically based shaders, I can do that as well. So this is the final look of the teapot. Next, that look was repurposed from another project that I did, where I basically created this kind of emblem for pen and ink, and it's something that I modeled using VR tools, textured in Substance Painter, gave it sort of an organic feel, and then applied these stylized looks on it, so it has actual feel of being hand drawn. And if we compare the original source, which is sort of this, I did some drawings for Inktober. Here's some 2D drawings on the left, or a 2D drawing on the left, and my 3D interpretation of it on the right. So that's sort of the round trip, if you will, from 2D illustration to 3D physically based rendering back to 2D illustration. So it's a very specific case, but it shows the power of the system. And just finally, I wanted to show you some of the IPR. So this is that shield, and I'm going to bring up a movie that shows you working with that in IPR mode. So let's see if I can find it. And it's going to be a little, it has to buffer up here, but this is Maya, and this is the shield inside of Maya. And what I'm going to do is add display filters to this scene. The shaders already have the NPR brains built into it. So let's take a look at this. So switching over, adding a display filter. So we get a background. Add another display filter, we get some lines. The lines basically are thicker where the normal is pointing down, thinner where it's pointing up. Adding some hatching. The hatching is driven by these different triplanar projections. Adding a Copic marker wash. And this is all an interactive session that I rendered on my laptop. And adding some specular highlights to kind of capture and really add a little bit of punch to the illustration. And now we're going to do a little bit of camera work. So I'm actually moving the camera and seeing the updates in IPR time, so interactive time, not necessarily real time, but what we call interactive. And so this allows me to really quickly dial in the look that I want, while also being able to utilize all of the things in my scene that I use with RenderMan, such as lighting and light filters and all that kind of good stuff. And so that's kind of why it's compelling. And we have our stylized looks coming to all our DCCs. So Houdini, Maya, Katana, and Blender. And you can stay tuned. So we'll be releasing this with R24. Beta is going to be starting early December, and release is going to be first quarter next year. So next, I'd like to bring up Ernst Groesbeek. And hey, Ernst.
Hey, Dylan. So
how are you doing?
I'm doing okay. It's getting dark here in Holland, so I put on some lights. So
cool. So I wanted to have you come today and show off this kind of amazing shipshape art challenge NPR treatment that you've done. So tell us about it.
So we took the assets from the RenderMan challenge, and we wanted to show what we can do with the NPR toolset. So here you see a quick build-up. I will go into detail later on, but you see the different AOVs we created. This is all done in Houdini, and you see that it's animated.
Nice animation too.
Yeah. The butterflies were a nice touch, I think. So if we go back to the beginning, and so the first thing we did was getting the lighting right. So we really wanted to have a more hand-drawn lighting. And so once we got that working, we started with the robots and also look how that works. And our goal was that we would have everything in RenderMan. So reduce the amount of post-production in the different software to the minimum. So this watercolor look is done in RenderMan with procedural textures. We did this in...
That's really cool.
We did it in Houdini, so that made it a bit easier. So the first pass we have is, for the lines, is the sections. So we draw lines around all the different objects. And we can do this per object or per shader, whatever we would prefer. And then we have this thin line. Then what we then do is use the option to make the colors, the line colors pick up the albedo color. And we do a small U shift so that they will stick out a little bit, but not too much. So then you get this effect. And what you saw here is that we did a distort. So get that hand-drawn look on the ship and on the objects, make it a little bit more imperfect.
That's really cool. It makes it look very hand-drawn.
Yeah. And we got this trick from your article on 3D World with the white marker on top, just to give it a little bit of a highlight. So then you get this effect. Put the clouds in, put the butterflies in, and then we have this effect.
That looks really great.
Thanks. So if we take a closer look, you see that we didn't do any hatching on the characters because that would take away the shape of the characters. But especially in the shadow part, it works really well. And again, here you see the highlighting. Based on the lighting, hatching on the robots, avoiding the clouds for the hatching. But because we can do everything in renderer and it's per shader based, so we can choose which one would have hatching, which ones will have lines. So that makes it really, really nice to work with. So, and then the hatching was one of the biggest challenges to figure out what would be a nice challenge, a nice hatching to look at. So here you see the lights and the hatching based on it. And we did a test with 4 different hatching types. So here you see the effect if you look at the whole picture, and I'll go into detail in a later slide. And the hatchings are made in a 2D software. And then what we do is we draw, we make 8 textures that are on top of each other like this. And in the lighter parts, you have or no hatching, as you can see here on the side of the cabin. And when it becomes a little bit darker, then the first hatching texture kicks in. and so on and so on. And because the textures don't tile, we don't have any problems with that. And what you see here, we did the same thing as we did with the lines. We did the hatching, pick up the albedo color, but because the hatching is already dark, we didn't do any hue shift. We just layered those on top of each other. And again, all done in RenderMan with different display filters daisy chained on top of each other.
Yeah, the progressive hatching really allows kind of like a unique style, so you can really dial in your particular look.
Yeah,
this one's really nice too.
Yeah. What I call it these days, not PBR but IBR, so imagination-based rendering. So
I like it.
So you can really.
I'm gonna steal that, Ernst.
Okay, no, you do that, no problem. So what I really like about it is that you can pick any style you want. So you showed some renders we did for TUI, and there you also can do anime, and you can do any style you can think of. So where did I go? Oh, and so here's the sneak preview of what we're doing at the end, or what we're trying to experiment with now is get the stylized rendering on fur and on hair. So this is moving. So here we have.
When you showed that to me, though, it looks amazing. It's really looking great.
Yeah, it's really the. This is what I like about it because it's interactive. You just start rendering and suddenly you get what you have when you start drawing by hand. You have these happy accidents. You're thinking, oh, this is cool. How did I do that? Okay, then let's make a preset out of this setting, save it, and then you can reuse it. You can even reuse it in different assets or even different scenes.
And just to be clear, in this scene, the dog's covered in hair, lots of hair. But you're able to draw just a few lines by using the hair color to drive a signal to the NPR system.
Yeah. So that makes it, really stylized in the way that I want it to look. So somebody else would do a completely different approach on getting the hairs and getting the style done. So if we would have a look at the, it's the same. So this is the same dog as this one, but because of the hair, it gets a completely different style.
It's really just based on your imagination. IBR.
Exactly. IBR. Yeah.
IBR. All right.
Okay.
Cool. So I think that was really fantastic. Should we roll into QA?
Yeah.
What do you think?
Yeah, let's do that.
Is Christos out there?
Is Christos out there? Let's see if he stopped surfing and he can join us.
Yeah. He might be getting some saltwater taffy in Tokyo.
Yeah.
Let's see.
Can you guys...
Hey, there he is.
It's Christos.
Yeah.
I love all the surfing jokes.
Yeah.
They're true.
Yeah.
They're all true.
They're true. Yeah. That's why they're funny. We're all jealous.
Yeah. Awesome work, guys. Ernst, really beautiful.
Thanks.
I'm getting a lot of messages, Ernst, for people who, the first time they've seen that work. It's
okay.
They're really loving it. So awesome job. And Dylan, your teapot is fantastic. I love how you did the projection, the animated projections, because they're kind of sticking but also dynamic. That's sort of, it's a kind of a fine line, and I really like how you did that, because they're not too static, but they're not bouncing around too much. So it's fantastic.
Cool, thanks. Yeah, it's fun to experiment with all that stuff, and adding a little more variation in the lines that could look a little more sketchy and illustrative. There's a lot of different ways to take it. Yeah. Let's see.
So if my Wi-Fi holds
here's a question. So far I could hear half of your sentence, so that's pretty good.
Okay.
So here's a question for you, Christos, from Sergey. Do we have motion blur with NPR?
Yes, we do. There are some challenges especially with like the line detection. It can get, because we're like kind of detecting it on data, so it's better if it's not motion blurred. So there are some challenges there, but it does work. You can also do like different interesting things with motion blur. So maybe creating like the line work based on the motion vectors. Can you guys hear me okay, by the way?
Yeah, sound great.
And then the hatching that holds, quite nicely over motion blur. The Kuwahara filter that we looked at on your teapot, that works really well with motion blur. So it's there. There are some challenges with it, especially with the edge detection. But certainly, you can apply it.
Cool. Let me see. I'm trying to read some of these questions here. And here's one. Can you reproduce with NPR a Disney-like stroke drawing that goes from thin to thick at the middle and then thin to again at the end? Intriguing.
From Oliver. Yeah, I saw that. Yeah, that's a good question. Yeah. So you can drive the thickness of lines with various things. So we kind of connect that to kind of a local object shader level. So you can, connect like a fractal based on the UVs of an object to go thick to thin, but that'll go sort of, because it's a fractal, it'll go thick, thin, thin. But if you want to like have very specific controls for that, then I would maybe use like the UV map. So if you wanted to go thick to thin on your arm, you can have a UVs going from 0 to 1, but then you can go into the shader and say, well, where the UV is 0, I want a thickness of like 10, which is quite thick in pixel width, and then you can even make it go to 0, kind of halfway down. But then you can also distort that line. So yeah, definitely we have those features in there, and you can drive them with textures, procedural patterns, and kind of on an object level. So yeah, that's really exciting.
Yeah, well, because I kind of touched on the pattern node a little bit on how you can wire in a triplanar projection, but you can do a lot of interesting things with it, such as having an albedo specifically for your NPR look, or having a line mask. So if I had a ball and I have an outline of a ball, but maybe I want to have some lines drawn on that ball, I could add a mask to it and get those lines drawn on the ball using the same type of technology on a per object basis.
Correct.
And
then the thickness kind of goes into sort of the thickness algorithm too. So it's not just, when I mentioned like a fractal, it doesn't look like a fractal, like it can get kind of wispy because it actually takes in like the thickness before it runs it into the algorithm. So it has a nice kind of wispy look where it could kind of fade off.
Cool. Here's a question along those lines. Can points be passed through to the system in the same way that the hair fur was used as an input to achieve a stippling type of effect?
Yeah.
Points by Michael Montai. I'm not sure what he means by points, like actual like
particle
effects
system or
particle points.
Yeah.
Oh, okay. Yeah.
Yeah.
I mean,
why not?
Yeah. As long as we have like just some basic data on the geometry, like if there are like surface normals, then that's kind of what we use for a lot of like the detection and a lot of the kind of effects. So I know a lot of like effects elements, if they don't have surface normals, then it just sort of limits sort of what we can do with that. But as long as we can get some data for any of those elements, then we can do the effects on them.
That's great. And how about a question for Ernst? What is the inspiration for your kind of storybook look?
But it comes from my childhood in the way that when we were read to as a child, these child book stories always had these very beautiful hand-drawn images, and that was my inspiration. And I met an illustrator who draws really freestyle images. And if you would look at Christos' website, there's a case study, and there are some examples of that work that we're trying to recreate. And especially we want to create so add the third or fourth dimension to it so that it will move over time and how that will look. So watercolor with hand-drawn images, something that makes me very happy.
Yeah, it's that's such a lovely effect that you achieved there. It's really great. And did you catch Ernst? He came up with this IBR term.
I heard that.
Yeah, it's pretty good.
There's a good question from Justin about the NPR lights. Can we take that one?
Sure, let's take it.
So Justin asks, for the NPR lights, are these controlled in display filter or on the actual light shader? So the NPR lights is sort of like a term, like they're not actually different lights. We branch off of the regular RenderMan lights, just like we do of the integrators on purpose, just so we don't have to do a whole new set of lights, which would be a whole nother project. And then also the RenderMan lights just have all these nice features, like all the filters already kind of built into them. And Dylan has done some cool examples with kind of playing with those. So basically the shaders, the display filters or sample filters, they just kind of branch off of the light. So you just put in whatever light group you've set up in Maya or Houdini or Katana. It works with all the DCC packages. You put that light group kind of in there, and then each display filter is basically just working on that particular light. And that can be the diffuse signal of your key light. It could be refraction. It could be direct specular, indirect specular. So really it can be any kind of, you could get really creative with it. It really puts the control in kind of the lighting artist or the cinematographer. So that's really cool, and you can mix and match them. So yeah, it's in the display filter, but you're sort of pointing to a light, and because you can daisy chain these display filters, you can do one effect on one light, do another effect on that light, but have different settings, then do like three other lights could be like physically based lights. So you can like really mix and match, but it really puts that kind of artistic control into the lights, as well as obviously it's all in the materials as well. So really nice control there.
Yeah, you can do
as well with the support for light group AOVs and light filters. Like there's a lot of flexibility as far as where you can target different stylization in the scene.
Mm-hmm.
I think we have one question, time for one question, quick question. We're going to be releasing the stylized look technology in R24, but it's going to continue to evolve into 25 and onward. And I think some of these papers, like the Kuwahara filter, are really interesting. How do you see it evolving in the future, Christos?
I feel like we've done a lot of cool stuff already, as we can see with the examples that Ernst 9:3 Animation has done and that you've played with, like the early adopters. So there's a lot of cool stuff to share right now, but at the same time, I feel like we're also just scratching the surface.
Yeah.
Like there's so much stuff that we're kind of getting into. Like we just, the Kuwahara filter, that's kind of a new thing that we're experimenting with. The painterly, then there's the brushed painterly that we've been developing for a while that looks good, but we're looking at different ways to make kind of more sticky brushes, and a lot of different ways to kind of do those techniques, and then just mixing and matching, not just having one particular look. It's always, when the audience kind of sees one thing or how you're doing it, you want to kind of keep them guessing. So it's really mixing and matching all these different styles with, doing it in the lights and adding the edge detect and different painterly styles. Like somebody asked on the question already today, like doing kind of a Van Gogh style with like swirly brush strokes, and there's so many different directions to go because there's no right or wrong way to do it. It's stylized. We're branching it off of the wonderful, physically based technology that, the engineers on the product are doing. So it's always kind of firmly rooted in that, but then we just go into different directions, and there's kind of no wrong way to go. And yeah, there's so many different styles to explore. So I'm excited, and even mixing it with photoreal all in kind of one shot, but having stylized in there for a character or environment or vice versa. So I'm really excited because there's so many different ways to go. So we've been doing it for many years now, as you know, and we're gonna keep on doing it, and it's gonna evolve. So it's exciting.
it's going to be great to get this in the hands of your users and see what they end up doing with it. It's going to be really fun. Well, I think that wraps it up. I think we did it. So, Christos,
good work, everyone.
Thanks for joining us from Tofino, and I'll let you get back to your vacation. Ernst.
Okay, thanks, bye.
Thanks for surf calls.
Yeah.
And Ernst,
hey,
always
thank
a pleasure.
You very much. Yeah.
All right, and thanks for tuning in, everybody.
Okay.
Ciao.
Ciao.
Thanks, guys. Awesome work.